So in this example, we're going to find the derivative of f and its second derivative. So carefully calculate the derivative as the limit of f of x plus h minus f of x over h as h approaches to 0. And this is the limit of x plus h quantity cubed plus 4 times x plus h quantity squared minus 3 minus x cubed plus 4x squared minus 3. This is the top over h as h approaches to 0. So I'm going to take the top of the difference quotient. That would be x plus h cubed 4x plus h squared minus x cubed. So x plus h quantity cubed is what I want. To calculate x plus h quantity cubed, I will go back to my Pascal's triangle and pick out the coefficients of the cubic expansion. These are the coefficients 1, 3, 3, 1. These are the coefficients for the quadratic expansion. Okay, for this square. If I had to the power of 4, I would have done 1, 4, 6, 4, 1. Add these two, add these two, add these two to get the next one. Okay, so but I want to do one with a cubic expansion, which is this one, and that would be 1 times x to the third, 3 times x squared h, 3 times xh squared h to the third, plus 4 times, for the quadratic one, I'm going to use these. So x squared, 1x squared, 2xh, plus 1h squared. Let me get rid of that. I don't need it anymore. Minus 3 minus x cubed 4x squared plus 3. This is x to the third, 3x squared h, 3xh squared, h to the third, 4x squared, 8xh, 4h cubed, now we see that x cubed minus x cubed cancel, and 4x squared plus and minus 4x squared are gone, and minus 3 and plus 3 cancel. So that gives us 3x squared h, 3xh squared, h cubed, 8xh, 4h. This is supposed to be squared. 4h squared. Okay, that's gone. That's the top. I'll put that in for the top in the difference quotient. So f prime of x becomes 3x squared h, the limit of three x squared h, 3xh squared, h cubed, xh, 8xh, 4h squared divided by h. Now factor h out and cancel will give you 3x squared, 3xh, h squared, 8xh, 4h. No, 1h is gone. 4h as h approaches to 0. And that gives us, so that will be 0 when you stick h in, 0 in for h, that will be 0. That gives us 3x squared plus 8x. And that's the derivative, the first derivative of the function f. For the second derivative, I'll take the derivative of this function. Okay. So this is my function. I'll use this function to find the second derivative. That will be the limit of f prime of x plus h minus f prime of x all over h as h approaches to 0. And this is the function x 3x squared plus 8x. This is the limit of 3x plus h squared plus 8x plus h minus 3x squared plus 8x over h as h approaches to 0. So I'll FOIL that to get x squared plus 2xh plus h squared. Distribute the 8x plus 8h. Distribute the minus, 3x squared minus 8x divided by h as h approaches to 0. That gives us 3x squared, 6xh, 3h squared, 8x, 8h, minus 3x squared minus 8x all over h. Now this 3x squared and minus 3x squared cancel. This 8x, this minus 8x cancel. This is as h approaches to 0. So that gives me 6xh plus 3h squared plus 8h divided by h as h approaches to 0. So if you factor the h and cancel, you get the limit of 6x plus 3h plus 8 as h approaches to 0. If you can't cancel the h, then you must have made some mistake somewhere. That's what it is. So now plug in 0 for h. This gives you 6x plus 8, and that's the second derivative of f. 6x plus 8. All right. I know this is a kind of long function, long video, but it gives us a different problem, a different example. And this is just it. This is the second derivative. Let me box the first derivative. This is f prime of x, and that's what we want.